who warmly joins me in wishing you a productive, inspiring, and importantly, enjoyable gathering. Hosting this one food waste stop meeting here in Zadar is not only an honor, but also a meaningful moment for our institution. After all, this action is one of the largest in the entire COAST program, bringing together over 900 participants from all across Europe and beyond. Clear proof that it comes to fighting food loss and waste, coordination at the scale is not luxury, but a necessity. The University of Zadar is fitting home for such an endeavor. Founded in 1396, our institution stands among the oldest universities in this. In the oldest university in this part of Europe, with a legacy stretching across centuries of intellectual life, reform, and cultural transformation. Although re-established in 2003, the university continues to uphold its historical mission to cultivate knowledge not as a static possession, but as a living, sometimes demanding, and occasionally stubborn force, shaped through dialogue, inquiry, and shared purpose. Over the centuries, scholars in these halls have faced the challenges of their times with a creativity and resilience. By welcoming you today, we proudly continue that tradition, this time with the PowerPoint presentations and very tight schedules. Our university is deeply committed to fostering interdisciplinarity, and this meeting reflects that spirit perfectly. Your program, spanning prevention of food loss and waste, innovative management solutions, quantification methodologies, and advanced valorization strategies in the circular bioeconomy, demonstrates just how complex modern food systems have become. What happens in fields, storage facilities, processing line, markets, restaurants, and households can no longer be treated as separate stories. This is why University of Zadar is proud not only to host this meeting, but also to actively participate in this action. Our researchers, including those contributing to the working groups and the local organization, are engaged in international cooperation that transcends disciplinarity and national borders. In many ways, Foodstop embodies the ideal of the modern university, a place where knowledge becomes actionable, where research meets real-world application, and where collaboration is not optional but unavoidable. And of course, no visit to Zadar would be complete without mentioning the city itself. Slaven mentioned something like that about the weather. I will just continue on that kind. Here, ancient stone meets contemporary life. Sea plays music through sea organ. You have probably the option to walk here and see these sounds of the sea organ. And according to Alfred Hitchcock, the sunset is the most beautiful in the world. Sorry for the weather outside, but I hope that you will have time to see that sunset. And now a few honest words again about the weather. You may already have already noticed that Zadar is currently presenting its full atmospheric portfolio. There is a lot of weather outside, and I must admit that we negotiate extensively with the weather authorities to secure sunshine, to see that sunset. But arguments were made, compromises were proposed, emails were sent, but we not receive any confirmation of that. So it's up to me to promise that for your next visit here, we'll just be more stubborn in securing the better weather to enjoy the Zadar here, maybe during the summertime, maybe during the summer, and we sure use and apologize for this failure of diplomacy in this moment. But I promise next time will be very good. And finally, I would like to express my sincere appreciation to the organizers, especially Professor Slaven Zjalic, who is already mentioned here and who made so many efforts to bring you all here, to organize that and to organize all these activities these days and to prepare everything for your stay here. I also thank Professor Gianfranco Romanazzi and all working group leaders for their scientific and organizational leadership, and of course all of you who traveled here, some from just across the Adriatic, others from the much further away, and your presence here enrich and gathering and strengthen our shared mission. On behalf of the University of Zadar and our rector, I wish you a successful meeting, fruitful discussions, new partnership, and innovative ideas that will resonate long after these 2 days are concluded here. May our work here help build a more sustainable, intelligent, and responsible future for food systems in Europe and beyond. Thank you, and enjoy Zadar in all its weather-related honesty. Thank you.
Thank you to the Vice Rector, and thanks to all you that are here for your valuable contribution to the cost action. Cost is a network, and then everybody can take its own contribution, and all together we make the action. So in this meeting, we will hear a list of oral presentations. Several of you will have the poster, but the most important part is that we will see each other, we will talk each other, we will plan future activity and maybe other cooperation that can lead to advance of the knowledge. And this cost action has a frame, and in this frame, an important part is made by the core group, led by the chair, but with a team of people, with the WUGI leader, and a big hand to the chair is from the vice chair, that is Fernando Perez Rodriguez. But if you want, you can give just a welcome.
Okay, thank you, Gianfranco. Well, it's a pleasure to be here again with you. So I'm really proud of having such a group working together. I remember one of the mails from you, Gianfranco, said that we are at, I could say, it is a team play. So we are working together. When one is having problems, we try to help. And at the end, what we are doing is just to collaborate and to have this integrative approach, just to try to reduce and prevent food waste and loss. Thank you, Gianfranco.
Welcome. Thank you, Fernando. And thanks to all the people of the core group, the WUGI leader, that we will hear along those few days, and all the people that will have a valuable contribution to the action. And now the word to the local organizer, Slaven Zelic.
Again, welcome here. It's my pleasure to see this large number of people here. I have followed some of your problems in arriving, etc., but everything, fortunately, is solved, and I hope that we will have really a good time today and tomorrow. What else can I say? You have seen where are our poster session. We will have during our breaks time to visit the posters, to read our posters, and we will have all the time to discuss here in this room about our oral presentation. Maybe Gianfranco, you say something as our, let's say, leader of the project.
Yeah, thank you. I will do by the stage. Okay, hello again, and here we are just to give a brief overview of what we are cooking within this cost action, together with Fernando and together with Marwa, that takes the secretary, together with Lucrezia, that is now she's following us at home. But she's very active, and she's dealing, and actually she will deal with all your reimbursements. So try to be brave on that, because better you are, less is her work. So we know that we have the loss that happens in the field and the waste that happens where we as consumers are engaged, so post-harvest, and then all of us are responsible of waste, whether if we are aware or not. Whatever we trash is not used, and we have to try to reduce this kind of waste, and we have to reduce in a sustainable way, so with the best possible approaches. And at EU level, there is a strategy called Farm to Fork that plans in the next year, basically, that we have to halve the food waste. Just one pathogen, one disease can cause all those waste that we can find in the basket of our fruit. But as well, we have to use less synthetic pesticides. So we will hear about alternatives, good alternatives, and the biological control, natural compounds, and so on. And we have to push on organic agriculture without the using of synthetic pesticides, because synthetic pesticides are not welcome by the consumer, are very important for the protection, but are can be an issue for the consumer. Then also the retailers try to reduce the amount of synthetic pesticides that are requested on the commodity, because they use this kind of synthetic pesticide as a kind of market share, so for their profit, of course, not of the consumer. And they try to promote different style. And this is from a review that Dov and I wrote. We have to think to our commodity with something under attack that we have to protect from the infection of pests and pathogens. But we are aware that we waste a lot. We have a high amount of waste. Most of those happens in our home, so of which we are responsible. So altogether, we with a bunch of you, with an initial bunch, we planned this activity that was funded, where we hypothesized a list of working groups, and the WUJI leaders are working very, very well. We will hear here in the due of the day. And together with the WUJI leaders, there is the number of participants. So we have several hundreds of you that join one or more working group. Of course, you know that cost funds your participation here, but does not fund the research. So it is in a volunteer basis. So everybody does what it can or what it links to your work. But altogether, we have to try to tackle loss and waste and to reduce them. So which are the main outcome or the main expected outcome? The meetings and the sharing of the knowledge, together with the promotion of the young minds that can interact with more experienced people, and everybody can take own results and discuss with others. So we started a couple of years ago, slightly more. So we are just we start the second half of the life of the proposal. We met in Ancona, we met in Cordoba, very nice meeting we had there, very nice video, and that is on the YouTube channel. And then the training school for young research innovators. We had a training school first organized by Natalia Falagan in Cranfield, a second organized by George Karagonidis in Thessaloniki. And short-term scientific mission. Several of you that are in the room here had this experience. It is a very good experience for young people that can spend time in a foreign lab and to learn something. It's not an holiday as a cost. Is not an holiday to join a meeting, but it is an opportunity, and try to take profit of those opportunities. These are just some of the exchanges that occurred, just some of them. So it is nice to see this kind of movement by one side or the other, And linked to this, there is at least one person that had this kind of tour, and so this is a growing of knowledge. So we promise something at the beginning, and we have to deliver. So we have to write something, and all of you are contributed to one or more deliverable. I just summarized some of them. And for example, we had a questionnaire on food loss, and a good bunch of people joined this questionnaire. A good bunch of people tried to promote the questionnaire. So Luca Falasconi, that is now in Bologna, he would like to come here, but he had some slight issues. So we will meet in next time. But he collected more than 1,000 answers to this questionnaire on citizens. But you see the countries, the participants of the country, they were country extremely active in promoting the participation to these questionnaires. So we had some webinars, and they are all on the YouTube channel to get information and to progress how to write a paper. So this was important as well, because we have to communicate, and we have to do things, and we have to communicate in the best way. And this is all resources are on the website. There is a part that is restricted to members. You have just to register for the first time, then you can get in. Some working group, for example, the WG4, is the more active. So congratulations to Jessica and to all the people that were working with him. WG4 already placed some materials that are linked to the participants of WG4, but are open to everybody. Whatever is in the cost action is public grants and need to be open to everybody. Then also, if you write something, it should be accessible to everybody. Then the publication needs to be open access, and because this is knowledge that can be shared and need to be shared. Social media, we try to work on, we try to update. Also, I saw that we are delivering on Zoom, where there is a bunch of people, hello to all of them, but it is delivered also on the Facebook page. And I saw there are some people that are following on Facebook. So there are ways for dissemination and where you can find information. We are growing, there is interest. I think that is one of the biggest cost action, but we can further grow. Just I arrived yesterday. I just opened the computer. 2 more people just joined here. So everybody is welcome. Everybody that wants to take a contribution. Turkey is an important country, and here Turkey is. Please, the people of Turkey raise their hands. Okay, good. Congratulations. 1/3 of cost action is from Turkey. So, but all the other countries participated. But have a look to the empty spot that can still be filled. So if you have some colleagues in a country that is not covered, you can tell that we are working within this cost action. And just in case you are interested, feel free to join. And I talked, since we have good grants, but never enough. I told to our scientific officer that was yesterday in the management committee, and I thought how we can further improve. And they thought, actually, you can involve more countries. How many? So, and this is the list of countries that are not covered. So if you know somebody from Iceland, Faroe, Lebanon, Palestine, Syria, or other countries that were not covered, tell them, and they are welcome, because thanks to this, maybe one of you can join next meeting. Because we are trying to with this mass, we are trying to apply for further grants, and this can be beneficial to join the meeting, for the training school, and for the short terms and distribution. So next training school will be in CESIS. So application will. You can save the date just in case somebody is interested. In the next days, we will have the application. And how does it work? There are no personal invitation. I'm sorry, because you are so many. So the invitation is through the newsletter. You have the link. You can apply in time. There are no, sorry, it was yesterday. I missed you didn't invite me. No, that there is one chance for everybody. Try to play your cards in the best way. So it will be more than 50 people that will be invited in CESIS. Jessica will give maybe some details on the structure when she will have the presentation, but she's working pretty well here with all the other people of the management of the board, with Sarah and others, and Victoria. As well, there will be new short-term scientific mission call, maybe within the month of February. And our opportunity, some of the people in the room applied multiple times for this short-term scientific mission. It is an evaluation process, so sometimes there are 5 awards and 25 people, so it need to be done a selection. So, but we try to do in a fair way, and Pervin Kinney is grant award coordinator that take care of this, and the core group then evaluate all the proposal and just apply. And here we are in Zadar, so very nice city. The weather, I'm sure that we will improve soon. Because the weather is proper to stay in the room and do not go around in this very nice city. So thanks, Slaven, for the work that you did. An applause for Slaven. I think that is more than welcome. And last but not least, we are working within a EU proposal that are public grants. So try to use them in a responsible way. A list of action has the eyes on by the cost. In our case, it is okay. So they are happy of what you are doing, but try to give by yourself your contribution. Do not stress Lucrezia, please. By some of you, we had 10 emails to Lucrezia. If all of you send 10 emails to Lucrezia, she will get mad and you will not be paid. So, okay. So thanks you all for your contribution, and let's go on all together.
Okay, in this short interruption between the proceeding of the program, I just wanted to give you technical information. As you have seen on different points, there are QR codes for the program and for the Book of Abstracts. The lunch is organized in a student restaurant here near, and my colleagues will help you to reach it. It will be at 1:15 with your participation accreditation card. Sorry, you have full lunch for 20 euros in our student restaurant. There will be very few students because it's a winter break, so mostly it will be for us. For those who have paid for our social dinner, there is also the QR code for the location from which bus is leaving this evening. You can find it on the reception desk. And I can say, I think you should ask Jelena, but I think that we have the possibility of getting other 10 people maybe for the social dinner. So if somebody didn't took it and is still interested, can talk with Jelena and she'll give it information. Thank you.
Thanks, Slaven. And now is the time to go into the details of the different activities of a working group. So I invite on the stage the WUGI1 leader, George Carago-Granigolis, and the WUGI1 co-leader, Alessandra Di Francesco, to show their activities. Thank you.
Good morning to everyone, and thank you very much. Now, Professor George Karoglanidis will present the VUG1 activities of the Prevention of Food Loss and Food Waste Working Group 1. Thank you, George. The floor is yours.
Thank you very much, Alessandra. Good morning, everybody. I would also like to welcome you here in this first part of the scientific meetings of this cost action meeting. I'm George Karoglanidis, the leader of Working Group 1, and in this short presentation on behalf as well of my colleague Alessandra Di Francesco, Professor of Plant Pathology in the University of Udine, I will provide to you an overview of the activities that have been undertaken under the umbrella of this working group. But in the beginning of this presentation, I would like to show you who we are. We are a quite large working group. Maybe I think we are the second largest working group within this cost action. We have reached a number of 500 members in this working group that are coming from 38 different European countries. But as you can see in the presentation, we have also participants from several other countries throughout the different continents. Of course, the majority comes from Turkey, as most of the other working groups. And let's see what we are doing. The main task of Working Group 1 is to deal with the prevention of food loss and food waste. So with our activities, we will try to understand and identify the food losses from the farm to the retailer, to perform different surveys across European and Mediterranean countries to identify opportunities that exist for sustainable quality and safety practices, and to develop some training programs in order to enhance the knowledge of the participants and the farmers and of students on the food loss prevention. Regarding the prevention of food waste, the second task of our working group, with our activities, we try to understand and identify the food waste, again, to perform consumer surveys across European and Mediterranean countries, to identify opportunities for sustainable practices, and also to establish links with consumers and to encourage the consumption of products that have some, let's say, irregularities, cosmetic or physical. How we try to achieve these tasks? We organize the activities of our working group in order to provide at the end 4 different deliverables. We were rather unlucky, let's say, because we were the working group that had to provide most of the deliverables relatively early in the process of our cost action. So until now, we have already delivered 3 of our 4 deliverables. You can see them in the presentation, but let's see them in detail. But before going to the deliverables, I would like to summarize an activity that we undertaking early last year in order to organize the preparation of the deliverables. So we organized an online meeting with all the interested members of working group 1. We discussed the way that we will work all together in order to prepare these deliverables. And we defined the leaders for the preparation of each of these deliverables. And after that meeting, we started working in order to be able to provide the deliverables within the time limit set by the proposal. The first deliverable, that one that had to do with the analysis and synthesis of the state of the art of the main problems causing food loss and waste. We defined Tamara Dapsevich as the leader, and with the collaboration of several other colleagues mentioned in the presentation from different countries. They made an amazing work, and we provided a deliverable in which we summarized the main problems related to losses and waste in meat products, dairy products, fruits, vegetables, cereals, and other type of commodities in the different parts of Europe, but also in other parts of the world. The deliverable submitted for the evaluation of the project and was approved by the rapporteur successfully. The second deliverable that we worked for was the preparation of a white paper about food loss and waste impacts, including some future perspectives. Here, Lea Kubikova from Czech Republic was the deliverable leader, and with the help of Dov Krusky that is present here in our meeting, and Elina Dace, they prepared the deliverable that was approved by the rapporteur with a comment that made all of us very happy, since he considered that it was a deliverable of a very high standard. And as you can see in this deliverable, we overviewed the food loss and waste quantities, impacts, and policies. We reviewed the detailed food loss and waste policies in specific European countries, 10 European countries, and Israel. We highlighted some crucial needs for the harmonization throughout the chain. We identified the main challenges at every stage of the food waste chain. And at the end of this deliverable, we provided some simple recommendations to various stakeholders in order to manage, to prevent the food loss and waste, and we also provided a vision for the future of the entire food production chain. The third deliverable, a deliverable that has to be provided by the end of the project, at the 48th month of the project, is the preparation of a handbook that will be translated in at least 10 different languages with guidelines on how to prevent food loss and waste. We also have started working on that. Michele Pedrotti from Italy is the deliverable leader, and till now more than 20 members of the working group 1 actively contribute to the preparation of this deliverable. As you can understand, the deliverable is not ready, but it's pretty sure that it will be ready earlier than the 48th month. That's the deadline for the preparation of the deliverable. And our fourth deliverable is the preparation of a review paper on the prevention of food loss and waste. Here, we have already achieved this target. We have, under the leadership of Victoria Crowder and Hisen Bitiki, that is also present, and some other colleagues that they worked with them. They submitted and published in the journal Sustainability a paper entitled Innovative Preservation Technologies Supply Chain Optimization for Reducing Meat Loss and Waste. In this review paper, the authors synthesized the latest advancements in new preservation technologies and supply chain efficiency strategies to minimize meat waste, and they also outlined the current challenges and future directions. But in addition to this review paper, we have already started working in the preparation of some more review papers related to the prevention of post-harvest diseases, with Alessandra Di Francesco as a leader in one of these papers. Stefanos Testebas is another leader for the second review paper. And Tamara Dapsevich works on the preparation of a review paper related to prevention of losses in cereals and oilseed rapes. Hopefully, some more review papers will be delivered by our working group until the end of the project, but these three are under preparation, so we believe that we will be able to deliver them. In addition to these activities, during 2025, we also organized a training school in Thessaloniki, my city, related to the prevention and management of pre- and post-harvest diseases. This training school was co-organized with Slaven and the working group 2 that deals with the management of food loss and waste. It was quite a successful training school. We invited 14 trainers, and we had around 30 trainees that participated. We had a quite intensive program of oral presentations on different thematics related to the prevention of post-harvest mostly diseases, and some practical exercises in the lab. And one day was dedicated to a field trip in some fields and some packing houses that work mostly with stone fruit. And I will close this presentation with some activities that we plan for 2026. Within the next few months, we will organize an online meeting of the VG1 members in order to discuss the progress of the third deliverable, the headbook that is under preparation, and also to discuss the progress of the review papers preparation, and also to discuss some ideas for new activities that we are going to have the chance to discuss as well tomorrow in the working group 1 meeting, in the thematic meetings of working groups. And after that, we will discuss that again all together in this online meeting. That's all from our part. Thank you very much for your presence, your contribution to all the working group 1 members, and to Alessandra as a co-leader.
There are any questions for George? Okay, so we can go on. Yeah. Thank you, George, and good morning to everyone. Today I will talk about the use of byproducts for the production of pullulan for the management of strawberries post-harvest diseases, in particularly the gray mold. So, but we have to do a little bit, little introduction about the post-harvest control strategies. Everybody knows that now the main admitted post-harvest strategies are focusing on alternative approaches, such as the use of microorganism, plant extract, and also edible coating, why not? And also providing good sanitation practices, because fungicide treatment are now mostly avoiding. All these strategies are focused on the prevention of food loss and waste, and of course, the realize of fruits and vegetables without any kind of chemical residues. In this case, we will talk about pullulan, that is a polysaccharide, tasteless, odorless, non-toxic, and also non-hygroscopic. It is a polysaccharide safe for human consumption and recognized by Food and Drug Administration as an ideal substance for application in different food-related fields and sectors, such as medicine, food, dairy, cosmetic, pharmaceuticals, and also industrial. It's composed by maltodextrin subunit, and the main producer is yeast, Arobasidium pullulans, that probably someone of you already knows as very good biocontrol agents, known for different mechanism of action against plant pathogens and post-harvest pathogens, such as by antibiosis, competition for space and nutrient, and also inducing of resistance in plant or other kind of host. So pullulan now is suggested to be used as an edible coating, but you know that could be also used for making biofilm, which is the main aim of using an edible coating, is to reduce the gas exchanges with the atmosphere of the fruits, and also have different activity, such as controlling the water losses of the fruit, controlling the oxidation, and also retain the textural properties of fruits. Also, it could be a very excellent vehicle for other compounds that can be added in the coating, such as plant extract, botanicals, or also live cells, so biocontrol agents. So it could be a coating and also a vehicle of active substances. In this study, we mainly focusing our activity on the control of Botrytis cinerea in the post-harvest of strawberries, and by different experiments conducted in vitro and in vivo. The first aim was to evaluate pullulan yield producing by a strain of our collection, Arobasidium pullulans AP1, that was grown on 3 different substrates by using 3 different byproducts derived from agro-food farm. And these are mushroom basal bodies, molasses, and grape skin. By in vivo, the aim was to assess the antifungal effect of this coating against Botrytis cinerea on strawberries of the cultivar Agnese. And for the last but not least aim, evaluating the quality parameter. So evaluate if the coating could change the common quality parameter of strawberries, such as hardness, pH, soluble solids, and also the weight of the fruits. So the first aim, as I said, we used the strain of our mycological collection of the University of Udine, AP1, that was the best strain in biocontrol activity and also in producing pullulan, as we reported in a previous paper that we published recently. What we know in this part, that we cultivated our strain in 4 different medium. The first was a common medium, isopolysaccharide medium, that is commonly used for the production of pullulan, and the other one by using the 3 different byproducts. So Sauvignon Blanc skin at 50%, mushroom basal bodies of Pleurotus striatus mushroom at 10%, and the molasses of sugar beet at 15%. What we did, we leave fermented the yeast strain concentrated 1 per 10 to 8 cell per milliliter for 5, 7, and 10 days at 25 degrees. Then when we centrifuged to remove the cells, and using the ethanol, the supernatant was mixed and left overnight at 4 degrees to separate the pullulan from the rest of the solution. After this, we left dry the pullulan and we measured the yield of the production. So as you can see here in the result, we didn't report any results for the grape skin byproduct because it totally inhibited the growth of Arobasidium pullulan and so the production of pullulan 2. And what we see that 7 days resulted to be the best timing of fermentation to produce pullulan by our strains. And as you can see in the first graph, by using the mushroom basal bodies of Pleurotus striatus, it stimulated the growth of Arobasidium pullulans, and its growth increased by 52.8% with respect of the isopolysaccharide medium that was used as our control. However, by our byproducts, molasses resulted to be the most promising and interesting byproducts, probably because it's very rich in sugar and it stimulates the production of pullulan by 209 milligrams per 100 milliliters. So just after the isopolysaccharide medium that is commonly used. As you can see, mushroom basal bodies were not so effective in producing pullulan by our strain. The second aim, as you can see, we evaluated the quality parameters of the strawberry cultivar Agnese by hardness, pH, soluble solids, and also the weight in pre and post treatment. For the second experiment, the same strawberries were sterilized by a solution of hypochlorite at 1%, then raised up with tap water, and then spray inoculated by using a suspension of Botrytis cinerea 1 per 10 to 4 conidia per milliliters. After this, the strawberry were coated with 3% of each coating that we use in this assay. So the pullulan obtained with byproducts of molasses, the commercial one, and compared to untreated strawberries. The untreated was just sprayed with sterile water. The strawberry were then incubated 6 days at 6 degrees, and then we check the percentage of incidence of gray mold. In the case of quality parameters, as you can see, I reported just the soluble solids and the percentage of weight loss because no differences were found for the pH and also for the hardness, that remain almost the same in pre and post treatments. But as you can see in the pre-storage, the use of coating slightly enhance the degree of the bricks with respect to untreated strawberry. And for the percentage of weight loss, I reported here the percentage of weight loss of strawberries, where you can find that the pullulan protects the strawberry in the weighting of loss, and so the percentage of losses with the treatment was just only on 1%, and compared to the untreated, where the percentage of losses of weight was by 5%. by the phytopathological assay, the using of edible coating, so with pullulan, reduced by 30% the incidence of the infection by Botrytis cinerea with respect to the untreated control, and almost was the same of the commercial pullulan, as we didn't check any significant differences between the pullulan that we produce by molasses and the commercial one. So after reaching these results, we just say some conclusion and comments that synthetic polymers, as you know, are gradually removed, replacing by new kind of polymers, probably more biodegradable and environmentally friendly. What we have to do with that study this kind of polymers, probably find potential pullulan strains that are higher producer of these polysaccharides, and working on these, such as working on the fermentation. As we said, with respect to the literature, we saw that prolonged fermentation could help the production of pullulans, and also working on the medium could be very important key factor to reaching a good yield of pullulan by Arobasidium pullulans. So what we saw in our study that this kind of coating improve better fruit quality of strawberries, and also protect strawberry from Botrytis cinerea. So, which is the message to take home, that many factors in this kind of study should be considered, such as the viability and the stability of a strain that we use for making this polymer, and the total absence of potential food safety hazards. Okay, this is a very important, and what we have to do forward for the protection in post-harvest management, of course, implement the fermentation substrate formula, and also including in it probably new byproducts, so helping also the environment, and obtaining so a pullulan with the optimal chemical composition, and is not the least point to optimize the cost for obtaining this very interesting molecule. So I finished, and I want to thank you for your attention, and I want to thank you, my colleague Rudy Cignola. And if you are interested, I'm presenting here our first paper about pullulan, where you can find more information about biochemical and technical application and characteristic of this molecule, and also why we choose this strain that I presented today now. Thank you.
Thank you very much, Alessandra, for your very nice presentation. We have time for one or two short questions.
No, I heard you. Yeah, we mainly use some literature data, and also because we want to detect very soon the presence of gray mold. As you know, that strawberry are very delicate fruits. We say we can use more or less the temperature of the common fridge that all the consumer has in their houses. So this is main the reason. Thank you.
Any other question? I have one short question. I would like to ask about the stability of pullulan. Can it be applied in the open field or just post-harvest level?
It could be applied in the field. Also mixing it with different co-formulation with more waxes, and there are now some products that are using also for the prevention of grapevine diseases in the field. So could be a potential polysaccharide, yeah.
Okay, thank you very much, Alessandra.
You're welcome. Yeah. Now we call here Dov Bruschi, okay, with his presentation about the quiescence in post-harvest pathogens. So Dov, the floor is yours.
Good morning. I will like to start thanking first the organizing committee, Gianfranco, for the kind invitation. Also to thank Slaven Zalak for his initial invitation here and hard work, and for sure to thank the organizers of the working group, George and Alessandra, for giving me the opportunity to present this paper that I have here. So this paper is a summary of some work that had been done in my last sabbatical, where I stayed in Beijing for some months. And it's actually it's a paper that has appeared in New Phytology 2 days ago, so it's open for your evaluation. Now, post-harvest fungal infections are initiated usually during or after harvest, but remain in a quiescent and dormant stage until the fruit ripens and becomes senescent. This is different from what is called in a different type of disease, like as you see Ustilago, that you see the whole disease developing in still developing host. In post-harvest pathogens, actually there is a way of penetration. Here, as you see in Caletotricum, you see the apressoria breaching the cuticle. That is direct penetration. The fungus can also penetrate by wound, as you see here, Alternaria germinating and penetrating a lenticel, or as you see also in Monilinia, where small wounds can lead to decay by just touching. What is interesting that during the fruit development until harvest, the fungus that has penetrated remain in a quiescent stage, and only after long storage and during shelf life, the fungus can start developing and show symptoms. Actually, what we see, the symptoms usually become visible only after maturation with prolonged cold storage during shelf life, just before consumption. In our work, we have compared the infection mechanism of post-harvest pathogen, mostly Caletotrichum botrytis and Monilinia. And as you see in Caletotrichum, you see spores. If I can show you the spores that has germinated and produced a globular apressoria. In the lower panel, that you see that the apressoria germinate and breach the fruit cuticle. In botrytis, the germinated spore produces an apressoria-like structure, because botrytis has no apressoria, but it has also an infection cushion, as you see in the bottom. Monilinia, on the other side, has a very nice spore that germinated and produced globular type of apressoria. Now, we try to compare the different pathogens in their quiescent stage, and we compare it to the roadmap of the infection of botrytis in the leaves until the first line of defense in the plant, what is called the pattern trigger immunity, PTI. This pattern trigger immunity impairs a baseline level of disease resistance during the first 48 hours in the infection, and include a series of processed cell death inducing protein, enzyme, toxin, pH modulation, activation of the plant HR, activation of spreading of cell death, and suppression of autophagy. we compare what happened in the different post-harvest pathogen. And here we took the result from botrytis in strawberry and grapes. And you see that in botrytis, whenever botrytis germinate and produce apresoria in the upper part, and then penetrate and lead to local death, everything is done. The main processes reported are between 24 and 36 hours. If botrytis penetrate directly through a wound, the whole process that I saw by just direct penetration occurs earlier, and a little later, a day and a half after penetration, there is activation of spreading cell death. So the whole process of quiescency that in infection and that affect the host is actually observed after 36 hours. And this is what is going on in botrytis. Botrytis germinate, producing hyalin apresoria-like or infection cushion that can penetrate the fruit or the tissue and kill some of the cell. And as you see, there is cell wall degrading enzyme, cell death inducing effectors, not many cells compared to what happened if botrytis penetrate a wounded tissue that has a more significant effect on cell death, and still it is become quiescent. Now, if we analyze the same roadmap in Colletotricum, we see that in Colletotricum, the whole process is a little bit different. In Colletotricum, about 15 hours post-inoculation, you start see pH changes, enzyme secretion, and addition activation of plant HR. But this is not at the beginning. What is happening at the beginning only if Colletotrichum can penetrate wounded tissue, and also in those conditions on the bottom, as you see in the wounded tissue is observed occurs about 15 hours after inoculation. Now, what happened during quiescency? This is what is mostly reported for Colletotricum. An epigenetic regulation. The fungus is thinking what it will do after the infection, and also there was a hormone regulation, phenylpropanoic activation, and all this is the main type of report that we see in the literature. As you see that the first the enzyme, the pH regulation, and the activation of plant HR are confirmed. But what is not confirmed in this system is the cell death inducing protein that are reported for botrytis. This is what you see in Colletotricum, a biotroph. You see that the melanized apresoria penetrate the cuticle and produce one or two cells only, not as in botrytis. There are more. The same process occurs in wounded tissue on the other side, and you see that the more cell death, but again, the only thing that is producing by Colletotricum cell wall degrading enzyme. So it is a little different from botrytis. Finally, Monilinia, one of the most fungus studied in Europe, has not a lot of data concerning the quiescency. As you see in apresoria-produced conditions after germination, the only thing that has been reported in the literature is enzyme production and activation of plant HR, but not other things. The whole process that is observed by direct penetration occurs almost immediately in wounded tissue, as you see in the here. Now, this is one of the problems that is still not known, studied enough, all this quiescent process in monilinear. The only thing it is very strongly reported is the hormone regulation and phenylpropanoic activation that occurs during the quiescency. And that is what is reported in the literature. As you see, what is confirmed is the enzyme production, activation of HR, and but most likely pH regulation is not known in monilinear, at least not reported. So finally, we can say that monilinear behaves, it is considered a necrotroph, but has a slight period of biotrophic. It produces a small penetrating conditions to cells that kills one cell, and that's the way of quiescency. While in wounded tissue, the amount of tissue that the cell that became dead is significantly higher. Only cell wall degrading enzymes are reported. To summarize, I can say that post-harvest pathogen first detect the host and then regulate the diverse metabolic process. They develop penetration structures, identify optimal entry sites, equip these structures with cutinase, lipase, and to breach the host cuticle, ensuring successful quiescency and inhibiting the fungal colonization and host immunity during ripening. In conclusion, that say that these findings suggest that the fruit in immunity during quiescency is characterized by a rapid and synergistic interaction process, not all of which are described. And this is the objective of my talk here, since Gianfranco is thinking about new subject for the next proposal, thinking about the importance of activation of infection. What is clear is they are differentially regulated across host species. Different pathogens behave in quiescent in a different way, and for sure they behave different during the stage of maturity of the fruit. This is coordinated regulation, enhance disease resistance, initiate a cascade of downstream defense respondents leading to fruit decay. So therefore, it is understanding to understand this host pathogen interaction mechanism, as it's activated, lead to the ways that this action is actually dealing, and we try to prevent. If we can prevent this activation, we can prevent the whole waste. Thank you very much, and whoever's want to see more specifically this data, you can see this open access paper that was published actually 2 days ago on the 1st of February. Thank you very much.
We have time for a question for Dov. Any question from the audience? No. Okay. Thank you, Dov. Thank you very much.
Okay, let's continue with the next speaker, Marva Moumni for Marche Polytechnic University from Italy, that she will present her work entitled Identification, Detection and Management of Seed-borne squash pathogens. Marva, the floor is yours. Thank you very much.
Thank you, George. So, squash is very important crop worldwide, and according to FAO, so in 2024, we reach 35 million tons of production, mainly in Asia, following by Europe and Africa. Unfortunately, this production can be lost due to many diseases, such as viruses, bacteria, fungi. We list some of them here in this slide, and all of them are transmitted by seeds, and seeds represent as a vehicle for them to move from a country to others. And you can see here in this table, there is many important diseases reach some country by seeds. So the seed quality is very important. How we can prevent this disease? So the first step is the seed health testing. Okay, and this is to help us to obtain seed quality and to build up a good management strategy, especially for the farmers that they use their own seeds and they didn't understand why my production is decreased year by year. So to answer for this question, we should analyze the seeds using seed health testing. Our study focused on squash crop, and we did a prospection in Italy and in Tunisia. We collect squash fruit from the farmers that they use their own seeds, and we collected symptomatic and asymptomatic fruits. Why? Because they are using, unfortunately, some of them, they are using these symptomatic fruits to extract seed and to use the next year. But other farmers, they are using appear healthy fruits to extract seeds and to sow for the next production. The question, these seeds extracted from asymptomatic fruits that appear healthy, are they with a good quality? So we analyze the seeds firstly with the conventional methods, bloater test following the ISTA rules. We incubate for 14 days, and then we analyze with the stereo microscope and the microscope. Then we did the morphological identification using universal primer, and also for the molecular identification, we use specific primer for some pathogens, and we design a primer for the species that we can not find a specific primer for them. So the results showed that 14 fungal species were detected from the squash seeds. Mainly, it was Alternaria alternata, followed by Stagnosporopsis cucurbita serum. The fruits that were collected from Italy, the symptomatic fruits that were affected by Alternaria alternata and Curvularia specifera, also the seeds were infected by the same pathogens, but for Stagnosporopsis cucurbita serum was present just on the skin of the fruits, but we didn't detect on the seeds. For asymptomatic fruits that appear healthy, we detect from that seeds Alternaria alternata that reach 36% of infection for some samples. For Tunisia, for the symptomatic fruits, the same 3 pathogens mentioned before, we detect on the skin of the fruits, but also on the seeds extracted from that fruits. For the asymptomatic fruits without any symptom, when we analyze the seeds from that fruit, we detect Alternaria alternata, Fusarium solani, but also the Stagnosporopsis cucurbita serum. This last pathogens was detected for the first time in Italy and in Tunisia, so we would like to go more in deep to search for other tools to detect these pathogens directly from the seeds. And at the beginning, we collect again the asymptomatic fruits. We analyze with the conventional methods bloater test, and the range was 1.5 to 65.4% of Stagnosporopsis cucurbita serum. We designed a specific primer able to detect these pathogens directly from the seeds. At the beginning, we start with the conventional PCR. You can see here the intensity of the band correlate perfectly with the incidence of the disease. We did also with the real-time PCR, and it correlates the morphological identification with the real time, but with the new tools, droplet digital PCR, we had a high degree of correlation. So this new technology showed a good methods to maybe in the future could replace this bloater test that take 14 days of incubation to have the result. While using this ddPCR, in 1 day, we can have the result. Is not enough to detect. We should search for strategy to manage. For seed treatment, we can have chemical fungicide, physical treatment, biocontrol agent, and also use a natural compound as a basic substance or as a potential basic substance. In our study, we focused on using essential oil, and we started with the in vitro study. We used 7 essential oil. We tested 10 concentration from 0.1 to 1 milligram per milliliter. We compare our result with standard fungicide using for seed treatment and with control seed like distilled water. And we choose the 2 main pathogens that were mentioned before, Alternaria alternata and Stagnosporopsis cucurbita ciarum. The in vitro study showed that lemongrass is able to inhibit totally the growth of Alternaria alternata at 0.6 milligram per milliliter. The same result with the same essential oil lemongrass showed a total inhibition for Stagnosporopsis cucurbita ciarum at 0.9 milligram per milliliter. To prove more, we continue with the in vivo study and we treat the seeds with the same 7 essential oil, but we choose 1 concentration that is 0.5 milligram per milliliter. We treat the seeds, we incubate using the bloater test methods, and we analyze after 14 days of incubation. But the important step when we are using the essential oil to see if there is an effect of phytotoxicity. So we measure the germination rate of the seeds and the length of radicle. All the essential oil, as you see here, are able to inhibit the growth of the 2 pathogens on the seeds. But lemongrass is able to inhibit and also to not have any phytotoxic effect for the germination rate and also in the radical length. So we go more in deep with the lemongrass and we treat the seeds with this essential oil we sown, and after 40 days we see the seedling emergence, and our results show that lemongrass improved the seedling emergence compared to the chemical fungicide and the control, but also able to reduce the incidence of Stagnosporopsis cucurbita ciarum on the plantlet of squash. So our study represents the first baseline characterization of seed-borne of squash in Mediterranean country as Tunisia and Italy, where the majority of the growers extract themselves the seeds. This cultural practice, like to select the asymptomatic fruits to have a seed with high quality, is not enough, because the seed health testing is mandatory to see the quality of the seeds. And also to study the epidemiology of the disease is very important to build up a good management. And for the management, as our case, essential oil showed a good result to inhibit some seed-borne pathogens. So the use of healthy seeds are the best weapon to prevent many diseases. And also sowing a local variety is very important because it's the weapon against climate change. And we know now the problem of climate change. So the local variety, it is really a key for climate change and to prevent the hunger. I would like to thank all the group that were behind this study, and thank you for your attention.
Marva, thank you very much for your interesting presentation. We have time for one or two questions from the audience. Alessandra?
Marwa, very interesting. Congratulations. I have a curiosity. When you received the seeds from the farmers, where these seeds were stored or received some kind of priming treatment before to find a fusarium or...
No. So we are with the farmers that they extract themselves their seeds. So it's not treated the seeds. So usually they store just in a place where there is not so high humidity, and they dry so good to not have any risk to be contaminated. But we collect not the seeds from the farmer, but the fruits that they use to extract the seeds. So we did more or less what they are doing. So the same steps of them, and then we analyze.
Okay, no, it's just to better explain if these fungus are epiphytes or endophytes, to search better strategies.
Which is the important point is to see the localization of the pathogens, if it is in the tegument, or it is in the cotyledon, or it is in the embryo. So we are working on that now, and some pathogens as Fusarium and the Stagnosporopsis are also in the tegument, but also in the cotyledon, and also could be in the embryo. Yeah.
Thank you.
Welcome.
Marva, thank you very much.
Thank you.
Dov, you have a question? Yeah, sorry.
Yeah, there is for the people in the Zoom to hear the question.
I just ask if the commercial treatment is heat treatment.
Yeah, some are using heat treatment, mainly are chemical fungicide for some, but for example, in Italy, the seeds are not treated, so they product a high quality of fruit, and they extract their seeds from that fruit. So the seeds usually are not treated. It depends from the country where you are, yeah.
Thank you very much, Marva.
Now we pass, thank you, Marwa. And now is the time for Professor Morasiotis from the Aristotle University of Thessaloniki, Greece. He will talk about sustainable technologies for reducing post-harvest fruit losses and improving quality.
Hello. First of all, I would like to thank the organizers and the COST meeting for giving me the opportunity to present my work regarding the application of some green technologies to reduce the post-harvest fruit losses and to improve fruit quality. So first, I would like to say as introduction that generally in the European Union, we have invested in the increase of fruit production, but at the same stage, we have several losses, not in the field, but during post-harvest. So these losses is not only economic, but represent wasted and in resources, energy, and labor. So if you want to have a really sustainable system, you need to reduce these losses. And the problem is that the last year, many traditional post-harvest technology, like the application of synthetic chemical, are banned by the regulation or by consumer. So we need new technologies, and one example is the green technologies. The green technologies, they offer the opportunity to reduce these losses and being environmental friendly. So in these slides, I will give you some examples of these green technologies that are used in modern post-harvest, like edible coating of LED technology of electrolyzed water. But I will focus in my talk in ozone and ultra UVC radiation. So despite the differences in the mechanism of action, both targets the same goals, reducing the pathogens and delaying the ripening. Ozone mainly applied in post-harvest physiology through water, as ozonated water, or as gas inside the cold storage rooms, while UVC applied as a short treatment, sometimes before or after cold storage. So today I'm going to show you two examples in a UV application, published works of my group. The first one refers to cherries and the other one in peaches. And also I will present you some data of our work in ozone. It is long-term studies in mainly kiwi fruit physiology. So we have published a work showing that the application, a short application, about 5-6 of UVC treatment, reduces the pitting. Pitting is a very important disaster of peaches, is the development of pitch, or the depression in the skin of the outer part of the cherries, and used mainly by mechanical stress or by cold. So you saw that this short treatment reduces the pitting in cherries, even either by cold or after depression, or as mechanical stress, as you can see here in the slides. So more recently, we published a work showing that we use the same experimental system, short experiment of UVC, in several peach cultivars, and we show that this treatment reduces the delayed ripening in terms of softening and the weight loss in peaches. So in order to investigate the mechanism behind this mode of action of UVC, we apply several approaches. So, for example, we perform several RNA analysis, RNA-seq analysis in several time points in several tissues, and using several bioinformatics tools, we identified the DRF1, it's a gene, a transcription factor related to ethylene signaling, is strongly upregulated by UVC treatment just after the treatment. So to investigate the mechanism behind this, we use several approaches like RNA silencing, the suppression of this transcription factor, and then expose the peaches to UVC radiation. So what we found is that the silence of this transcription factor reverses the effect of UVC, indicating that these genes involved in the action of UVC. And also we try to propose a model of and connect the ethylene signaling by ERF and UVC with other signaling, for example, ABA, salicylic acid, and oxygen. So as I said before, I will move now to our work in kiwi fruits. We work many years with regarding the ozone. This is the long-term experiments. We use the red class, the Hayward, which is the dominant kiwi fruit cultivar for our system, and we use generally kiwi fruit as a model system for ripening, because kiwi fruit cold stores for a long period, for example, for up to 6 months, and also have a very specific ripening behavior that strongly depends from the ethylene. So our journey in application of ozone in kiwi fruit started by studying the botrytis, which is a major problem in post-harvest physiology of kiwi fruit, and we found that the continuous application of gas, ozone, for 4 months inside the cold storage rooms reduced the symptoms of botrytis. So, as you can see here, in the infected fruit form scleroidria, while this not occurred in ozone-treated, ozone-exposed fruit. So we also in this work found that the application of ozone inside the cold storage rooms reduce the level of ethylene inside the cold storage rooms. So indicated or providing first example that ozone may affect the ethylene level inside the cold storage rooms. So to investigate at the level of fluid this, we cold stored Hayward fruit for 1, 3 or 4 months, and then allowed to ripen at room temperature. And we identified in the presence of ozone the ethylene production. So what we found is that the exposure of ethylene, and especially after long-term 5 months, reduce the production or inhibit the ethylene production from kiwi fruits. So to explain this, we try also to investigate some parts of the ethylene biosynthesis, and we found that ozone exposures depress some key enzymes like ACA oxidase and synthase that involved in ethylene production in kiwi fruits. So apart studying the ethylene signaling, we found that ozone exposure reduced the softening, which is another big problem in kiwi fruit physiology. So also we try to explain this by analyzing some components of the cell wall, the architectural cell wall, and you can see that ethylene, for example, induces the inhibition of some key enzymes involved in the softening of kiwi fruits. So in order to investigate the effect of ozone, we try to add additional questions in our study, and we apply a wooding treatment. So here you can see in the slides, this treatment is an artificial injury by needle as a wood treatment, and we found that this wood treatment induces a very rapid production of ethylene. So the question is, what we do is to apply this wood treatment, and then we exposed the kiwi fruit, the wooded kiwi fruit in ozone. And we found that the ozone delay the ripening and the ethylene production even in the wooded fruit, so indicated that ozone may also be quite effective against mechanical stress. So for our work, an interesting question is the interaction of ozone with other ripening molecules. So I will give you 2 examples on these questions. The first one refers to application of 1-MCP. 1-MCP is a very known chemical in post-harvest physiology, very effective inhibitor of ethylene action. So the idea is we apply 1-MCP, and we found, as we found also already in ozone, that both depress the ethylene production. So to investigate how this molecule interact, we apply a combined treatment. I mean, 1-MCP plus ozone. And we found that this combined treatment induces very strong inhibition compared to individual treatment with ozone or either or 1-MCP. So this is a clear example that there is a common action between 1-MCP and ozone. So to investigate further this connection, we apply a protocol of external ethylene application. So we found that external ethylene application induce a very rapid endogenous ethylene production in kiwi fruit. So the idea is to apply external ethylene in kiwi fruit that exposed to 1-MCP and ozone that show inhibition of ethylene action. So what we found, and for me it's very important, is that the kiwi fruit that are exposed to ozone can produce ethylene after external ethylene application, but this not happen in 1-MCP treated fruit. So this means that ozone just inhibit the biosynthesis of ethylene, while 1-MCP also reduce the ethylene production. So in other words, the kiwi fruit after ozone can smell, can sense the ethylene and ethylene signaling, but this is not the case for 1-MCP treatment. So another interesting molecule in as green technology is nitric oxide. It's another gas, and we found that one treatment with nitric oxide has not effect in kiwi fruit ripening, but can act only in the presence of ethylene, of ozone, indicated a very complex. It's not clear for me still now how interact these both gas in post-harvest kiwi physiology. So very interesting question is whether ozone also is effective in other fruit species. The answer is the effectiveness of ozone is species dependent, and in order to support my opinion, I will give you the last example. We apply the same experiment, as I said before, in kiwi fruits in Granny Smith. Granny Smith is green, well-famous apples. And treatment with ozone has no effect in the ripening of Granny Smith apples. But we observe that the application of ozone induces superficial scale. Superficial scale is a very big problem in post-harvest physiology of Granny Smith. It's a browning in the skin, only the skin of Granny Smith. And that is also very important that the application of 1-FCP totally reversed this effect, this negative effect of ozone. Indicated again that the action of ozone depends on the species and may be carefully managed. So as final conclusion, I think that green technologies may offer the opportunity to change the handling of fruit. And for me, a major challenge is to understand how this treatment act together. For example, now we're working with the interaction of UVC and ozone, because taking also into account that the UVC treatment induces the production of ozone. So it's very interesting to investigate the combined green technology treatments. I would like to thank all the collaborators, especially the members, old and new, of my lab. It's been a pleasure being here. Thank you.
Thank you very much. We have time just for a quick question. Professor Romanazzi.
Very interesting presentation. It is known that ozone can be phytotoxic, but it depends on the concentration. So
yes.
Do you think that changing the concentration, you can have the same effect, or they may, I don't know,
yes,
vary?
Yes, the concentration is important, but I think the problem, for example, with ozone, it's very aggressive because it's oxidative. For example, I will give you an example in cherries. Even in very low concentration, can induce the browning of the petal. So I think, okay, it's very important, the concentration, but generally must be carefully handling the ozone.
Very quick, Doug.
This actually tells us that we don't have to use always fungicide or treatments that to kill the fungus. If we can modulate the ripening of the fruit in some way, this is also a way. I understand that there is no single bullet treatment. So the combination of many of those treatments that might be ozone, in this case, affecting the ethylene biosynthesis, or other things affecting in some way the oils that you are using altogether. These are things that altogether might lead to a green type of fruits that come to the market.
Thank you very much. So.
Now it's time for a coffee break. But before the coffee break, I would like to invite all the speakers of the next session to upload their presentations. And I would also invite you to be here at 11:15 precisely in order not to have delays in the next session. I would like to thank all the speakers for this first session of our program. And Slaven has something to announce.
Please don't leave the room. We will make now the picture here. We wanted to make it outside, but unfortunately you see the day, and so we'll make a group picture.
And so all the participants, please sign the presents in the paper of the cost for your reimbursement, if you want to be reimbursed.
contact. I can.
Well, time to start the second part of our session. After having this nice coffee break, we will continue with Kata Ludman-Mihaly from Hungarian Professional Organization for Fruit and Vegetable. Kata will present to us her work about the inhibitory effect of soluble metabolites of Trichoderma afroharzianum on the mycelial growth of post-harvest pathogens. Kata is already on the floor. Kata, please.
Can I start? Okay. So my name is Kata Ludman-Mihaly, and today I'm talk about a small study about Trichoderma afroharzianum. I think everybody know that invasive pests and plant disease cost for the global economy about $220 billion each year. And at the same time, we have a fruit and vegetable supply deficit because we already don't produce enough fruit and vegetables if we consider the recommended intake levels. And also here is the post-harvest losses, and this makes this gap even larger. And the consumers increasingly react the chemical residues and they want to eat safe food. So we have a double challenge that somehow we need to reduce the post-harvest losses. Via we use less fungicides and use more, use more, it's better, use more safer alternatives. So for this reason, and of course other reason, Green Deal was created. And in the case of Farm to Fork, one goal is about reduce the use of pesticides and increase the organic farming. So we have a lot of possibilities, but the most research topics is biocontrol agents. And the antagonists can help the plant protection in different way. For example, compete for the nutrients and the space against the post-harvest pathogens or the pathogens. Some of them mycoparasitic, they can able to produce different antimicrobial compounds, and they have a positive effect on plant. For example, they can induce of the plant resistance or the stress tolerance. If we use this kind of product, there is no residue and food withdrawal period, and it has a low ecological impact. So most of Trichoderma species live in soil, but there is some which live in rhizosphere or in or on the plant. And they have different biocontrol properties. I just would like to highlight some. For example, indirect way they can induce the systemic resistance or do grow promotion. But they are also really good mycoparasitic, and they grow rapidly. So this way, the competition for the nutrients and the space is really good, really effective. And they can produce different antibiotic compounds, such as chitinase or gluconase, and secondary metabolites, which can be volatile or non-volatile substances. A few years ago, Elizabeth Carafa and her team isolated from the woody tissue from cordon of grapevine this Trichoderma afrohartianum species. And this study, we wanted to see that this species can inhibit with soluble metabolites the post-harvest pathogens. So first, we product the secondary metabolites and non-volatile substances. For this, we use 3 days old strain. We put potato dextrose broth. We incubate it for 7 days with shaking, after centrifugate, after filtered, and we put the pedia media with different concentration, 10, 20, and 30 concentration. So what kind of fungal species we tested? We isolated from the surface of sour cherries, and after the molecular identification, it were the Alterna alternata, Collotridium godati, Botrytis cinerea, and Fusarium sporotrichoides. After, when we inoculate, we measure the daily growth of mycelium and calculated the inhibitory effect of growth. So I would like to show our small results. Sorry. Here in the diagram, you can see the average daily growth, and in the table, you can see the inhibitory effect. So in the case Alternaria alternata, all the free concentration had an inhibitory effect, but in different rates. The most effective was the 30% field rate. And with the Fusarium sporotrichoides, we had a different results, because the 10 and the 20%, there was no inhibition, but the highest concentration has a significant differences. In the case of Collotridium godati, unfortunately, there was no inhibitory effect, which can be detected. And in the case Botrytis cinerea, the inhibition was visible, but the statistical difference was not observed. So, summarize our results. We can say that the soluble metabolites of Trichoderma afrohartianum had effective growth inhibition in the case of Alterna alternata and Fusarium sporotrichoides. Collotridium godati and Botrytis cinerea, no statistical difference can be detected. And our plan after that first we would like to analyze of these field rates, and we would like to test it on more post-harvest pathogens. And after that, we would like to do implant post-harvest treatment. So that's all. Thank you for your attention.
Thank you very much, Kata. Any question from the audience? I have one question. I would like to ask about the source of this trichoderma species that you use in your research. From where did you isolate the strain that you used?
Can you repeat again? Sorry.
I'm asking about the origin of the isolate that the trichoderma isolate that you used in your experiments.
Yeah.
From where did you isolate the strain?
Yes, from the grapevine. We isolated from the grapevine, from the cordon part, from the woody tissue. Okay.
Thank you.
In matter of this, Kata, thank you very much for your presentation. I have a curiosity. So in the future, you will test Trichoderma metabolites mainly for grapevine diseases in the field. Could be the right way to use these filtrates, or you should use these filtrates also for other commodities on fruits post-harvest? What do you think about this?
Yes. And Elizabeth tested more other products, and this was the first work that we would like to see, that this kind of metabolites just alone can do something with the post-harvest pathogens or not. Yes.
Thank you very much, Kata.
Thank you very much.
So now we move to Professor Stefanos Testempasis from the University of Western Macedonia, Greece. And his presentation is control efficacy of a new SIG-based biofungicide against Penicillium digitatum on citrus fruits.
Good morning, everyone. First, I would like to thank the organizing committee for giving me the opportunity to be here and presenting my part of my research on the control efficacy of a new spray-induced gene silencing based biofungicide against green mold disease on citrus. This research responds to the European Green Deal demands for sustainable agriculture. As we all know, we are expecting a significant reduction in the synthetic pesticides, so the need to find new sustainable control methods is a necessity. On this concept, we have the recent years, several biotechnological tools have been suggesting, like the RNAi, RNA interference. RNAi includes two major categories: the host-induced gene silencing, which involves GMOs and is under the European regulation for GMOs. But we also have the spray-induced gene silencing, aka SIGs, that fits within the European regulatory as plant protectants and represent a promising tool for control management methods. Green mold disease is one of the most important post-harvest diseases of citrus. It is caused by the fungus Penicillium digitatum. Until now, disease management mainly relies on the use of synthetic fungicides, but due to the high risk of development of fungicide resistance and the increasing concern of consumers for food safety, push us to find and explore new alternative control methods. RNAi is a naturally occurred gene silencing mechanism found in eukaryotes. It is triggered by double-stranding RNAs that leads to the degradation of specific messenger RNA. In detail, double-stranding RNAs are processed into small interfering RNAs. These small interfering RNAs are loaded in the RISC complex, and with the help of the Argonaute proteins are binding to the target mRNA, cleaves the mRNA, and leading to its degradation and gene silencing. So the aims of the study was to select and design the target genes that we want to target in this study, and to in vitro synthesis the double-stranding RNAs to evaluate their effectiveness against green mold disease on citrus fruits, and also to investigate the control efficacy of the small interfering RNAs obtained from the respective double-stranding RNAs. This research was initiated by and get inspired by the existing literature, but the main idea was to develop this SIG-based biofungicide to target the essential genes that are involving in the RNAi machinery. So we design double-stranding RNAs that they targets the Argonaute genes and the dicer genes. We further in vitro synthesized these double-stranding RNAs using a commercial kit, and we in vivo tested their efficacy in several citrus hosts. Our experiments were mainly conducted in orange fruits of Cultivar Sallustiana, More specifically, oranges were surface sterilized, and after that we perform artificial wounding. We apply the double-stranding RNAs on the wounding site, and after a short incubation period, we artificially inoculate the fruits with a spore suspension of Penicillium digitatum. After that, the artificially inoculated fruits were stored under ambient condition and incubate for 5 and 10 days. After the incubation period, we perform a disease assessment by measuring the disease severity and the disease pressure index. Moving now to the results section, and more specifically on the efficacy of the double-stranding RNAs targeting the Argonaute genes against Penicillium digitatum. As you can see at 5 days, the double-stranding RNAs targeting the AGO1, AGO2 genes significantly reduce the disease severity of green mold, while at 10 days post-inoculation, this great efficacy maintained for the same exact treatments. As for the double-stranding RNAs targeting the Dicer genes, at 5 days post-inoculation, only the double-stranding RNA targeting the DSL1 gene revealed a significant reduction in the disease severity. But at 10 days post-inoculation, none of the treatments reveal any significant difference. In overall, at 5 days post-inoculation, the dsRNA targeting the AGO1, AGO2, and DSL1 gene exhibited significant lower disease pressure index values in comparison with the controls, and the application of those dsRNA inhibited disease development by 95, 97, and 98% respectively. At 10 days post-inoculation, the double-stranding RNAs targeting the Argonaute genes maintained a great efficacy, even 10 days post-inoculation. But on the other hand, the efficacy of the double-stranding RNA targeting the Dicer1 gene declined, suggesting that the targets of Argonaute genes are more stable and effective through time. So for this reason, we continue our experiments targeting these two genes. We further test the efficacy of the application with the double-stranding RNAs targeting the Argonaute genes on other two citrus hosts, and more specifically on mandarins and lemons. The results that we obtain are very similar with those from the orange trials. And as you can see, the disease inhibition to all tested citrus range from 75 to 94%. We further investigate the efficacy of the small interfering RNAs obtained from the double-stranding RNAs targeting the AGO1 and AGO2 genes by following the same experimental procedure. The results that we obtain are were more greater than those from the double-stranding RNA application, since the control efficacy ranging from 92 to 99%. Observing these promising results, we wanted to further investigate what happens with those small interfering RNAs, so we perform a small RNA sequencing in order to answer some very important questions. For example, which small interfering RNAs we have, in which abundance, what's the size, what's the length, and the strand orientation. So the results from the bioinformatical analysis revealed that the majority of the small RNA sequencing that we obtain are perfectly mapped on the, under the gene of our interest. Most of the sense interfering RNAs are found to have a length between 18 and 21 nucleotide lengths, while the antisense small interfering RNAs that they are more substantial for, on these studies were found to have a length of 22 nucleotides. In conclusion, among all the target genes, the greatest efficacy was noticed, a greater efficacy was noticed in the treatments with the double-stranding RNAs targeting the Argonaute genes, while we observed low control efficacy in the treatments with the Dicers. The application with double-stranding RNAs targeting the Argonaute genes demonstrate high control efficacy against green mold disease across various citrus fruits and the incubation period. In the small interfering RNAs application, we observed even greater control efficacies in comparison with the double-stranding trials. since we observed a high disease inhibition rates more than 92%, even after 10 days post-inoculation. And finally, the small RNA sequencing revealed the prevalence of 22 nucleotide antisense small-interfering RNAs targeting the AGE1 genes, which is very important because based on the existing literature, we know that the antisense small-interfering RNAs with this exact length are more active and more effective for triggering the RNAi machinery. At this point, I would like to acknowledge all my colleagues back in Greece for the effort to this project, and of course, all of you for your attention. Thank you very much.
Thank you very much, Stefanos. There are any questions from the audience? Dov. Wait for the microphone, Dov. Sorry.
Maybe I missed that you didn't do competition analysis of both strains, meaning combination of 50 to 50% of spores. So this is one. Second question is what happens if you inoculate the day after the double strain is applied, 3 days after? If you think about commercial conditions, you expect to spray the people
Okay. Regarding your first question, no, I didn't perform any competition test because when we start this project, we're trying to evaluate if these double-stranding RNAs has an in vitro effect against Penicillium digitatum, and as we expected, it does not have any effect because we're targeting the RNAi machinery genes, not genes that are very essential for the fungus to develop. So that was something that we expected, and according to the literature, is a valid result. As regarding your second question, I think that we are not able to go further for to think application in the field at this point because this kind of application is too expensive to reproduce these double-stranded RNAs in high volumes. So we start the trials in vitro conditions. But as for your question about the period that we applied the double-stranded RNAs, we know for sure that if you apply the double-stranded RNAs at the same time with inoculation, we have no effect. That means no effect. That means that the double-stranded RNAs or the small interfering RNAs need some time to interact with the host, because this kind of application with RNAi targeting the machinery of the RNAi it's more complex than the simple that the most simple RNA application, the double-stranded RNA application targeting the genes that targets the fungus, because we know that Argonaute genes and the dicer genes get into the host interaction complex, works as effectors for a lot of pathogens, and it's not just that does not have a fungicidal effect on the fungus.
Thank you very much, Stefanos. There are any questions? No. Okay. Thank you very much. A big applause. Thank you very much to all the speakers. We have finished this session. And
now it's time to invite Slaven Louis, the leader and the co-leader of the Working Group 2, for their session.
Thank you.
organizer.
Oh, sorry. We will start with a briefing from Slaven about the activities and the deliverables of this work group. Thank you.
So, once again, good morning, everybody. We are still in the morning. Before I start to talk about the progress in achievement and the plans for the VG2 for our work group, I would like to kindly thank all the participants in this group, all the people that dedicated their time and contributed to the work of this subgroup. And I would especially like to thank Erzsébet, Piotr, Anna, and Luis, which are the leaders of our subgroups that I will explain you also in my presentation. I've seen that our working group now has reached more than 450 members. It would be very nice if all of them were active, but we hope that with time everybody will activate it. And we have members from all over the Europe and including some countries out of Europe like Brazil, Azerbaijan, China, India, etc. New Zealand, South Africa, Tunis, United States, Morocco. And if I jump somebody, please forgive me. What was the task of this group? We had different tasks. First is to identify different management strategies, create roundtables, develop collective new scenarios, determine appropriate new sustainable strategies, and build consensus on potential new solutions. Establish links between conventional and organic farming to inform farmers that alternative or biological control can be usefully applied. Develop food loss and waste think tank, and create a platform for knowledge brokerage. And evaluation of the potential to use new innovative strategies to control post-harvest decay methods. All this leads us to our activities that we are doing. So it's at least 10 in-person and online meetings with multidisciplinary groups, and we are having generally at least one online meeting of the whole group. We are having also our in-person meeting on each of the conferences, and each subgroup has also the meetings of the subgroups, and this activity will go on till the end of the project. We have to do to participate at least 4 training programs. We also, it's an ongoing activity. We participated and organized co-organized the training in Thessaloniki, and we have to do this consumer campaigns. Our deliverables are 3. The first one is the next to come. It's protocol of best practices to reduce food loss and waste, guidelines for sustainable food systems that should come in by the end of the project. And the one that is accomplished, it's a review of applications on agri-food loss and waste management. What we have, how we have proceeded, I just nominated that we have 4 subgroups. On our first meeting, we realized that there is a big differences between the expertises of our members, and that maybe the best way to approach it would be to try to focus on a bit smaller topic areas. So we decided to create 4 subgroups, one dealing with fruit, one with vegetables, one with cereals, and other connected to animal production, let's say. And we have subgroup leaders, and each subgroup is working autonomously, but then we are all connected together and producing the final result that will be common and not connected to the subgroups. The deliverable 2.3 has been achieved. We put our review on literature on the management of food and loss in cereals in post-harvest period. Now we will, for let's say, at the end of the project, we will also add the work that is still in progress from other 3 subgroups to make a common document. We are also preparing publications. The animal production subgroup did some publications. Cereal subgroup has submitted one paper. It was reviewed. Now we have to answer and to adjust it, and I think in 1 month we will present it. And the other 2 groups are working hard on preparation of their review papers, and each of these groups had planned more than 1 paper. It's not easy because we are here all volunteers. It's not easy to put all the people together. It always gets some time, but we are managing this, and we are going on with our work. And I think that on the next meeting, cost meeting, I will be able to tell you that each of our subgroups has published more than 1 paper. What we have to do in the next period? Yes, we are slightly in delay with the deliverable 2.1. We should close it by the end of this month, and we will start now. But it was planned like this because the basis for this good practices is based on our literature reviews. So we will start tomorrow organizing it and prepare it. So in a few months, we will have our results in that part. And then we have the biggest maybe deliverable, the guidelines, and the preparation of guidelines will also start tomorrow. We'll start it here on our group meeting. And thank you. In short, that was our work of working group 2. So me and Luis, we decided to do a lot of gymnastics, so walking from one part to another. I did my share of it. Now it's time for Professor Palou. He will give us his presentation on management of post-harvest decay of fresh citrus fruit without using conventional chemical fungicide. Professor Palou is...
Thank you, Slaven.
Okay, you represent your institution then, okay.
Yeah, I'm coming from the IVIA, the Valencian Institute of Agrarian Research, which is a regional government research institute of the Valencia region in Spain. As you can see here, most of you know, is Valencia, and this is one of the most important citrus producing areas in the world. So yes, citrus are our main crop to work with, but we also work with other Mediterranean crops such as stone fruit or grapes, or especially pomegranates and persimmon, which are, and now also avocados, which are an increasing crop in our region. So I'm working on post-harvest pathology of these Mediterranean crops. So the idea of this presentation is not to present to you any specific or recent results we have obtained on our research, but to give you, let's say, a general view of what would be or what can be the control of green and blue molds without the use of post-harvest fungicides. So we can see here that maybe you have seen these nice guys in your fridge sometimes. This is green mold caused by Penicillium digitatum and blue mold caused by Penicillium italicum. After Stefano's talk, you are a little bit more familiar with Penicillium digitatum. So as Stefanos has said, these are the most important post-harvest pathogens of citrus in our Mediterranean conditions. Mediterranean would be the same than, for example, California or South Africa, most areas in South Africa, which are less wet, with less humidity than other citrus production areas, like, for example, Florida or Brazil, where they got other also important post-harvest pathogens. But in general, but these are also important in those rainy areas. These are also important there. So as we know, and many of these colleagues working in this cost action on post-harvest pathology aware of the problems related to the post-harvest treatments to control these diseases with synthetic chemical fungicides. In the case of citrus, we were talking about imazalil, pyrimethamine, so synthetic fungicides which are applied after harvest to control these diseases. Main problems are that these treatments leave residues on the fruit, and these residues can have adverse effects on the health of the consumers, etc. So if we are not going to use these fungicides, also they got many problems about regulatory regulations of the use of these fungicides. So every year there's more problems to use them, especially for specific markets. So we need to approach an alternative control strategy. In this case, I call that as non-polluting integrated disease management, NPIDM. This would be a kind of concept of integrated disease management in which it's very important the knowledge of all pathogen epidemiology and all pre-harvest, harvest, and post-harvest factors that can influence the incidence of these post-harvest diseases. And then take action at the right time on every of these factors in order to be always through non-polluting means in order to minimize the economical losses caused by these pathogens. So the actions can be, of course, before harvest, at harvest, very important in the case of Penicillium because most of the wounds that are infection paths for the pathogen. So as Stefano said, Penicillium are wound pathogens, strict wound pathogens. So if the ring of the fruit is not broken, the fruit can be contaminated, full of the spores. But if there is not a wound, the spore goes into this wound. If there is not a wound, it will not be an infection. So the fruit can be contaminated, but not infected, but infection is only through wounds. So, and many of these wounds are produced during harvest. So that's the why actions at harvest are also very important. But we focus here on post-harvest actions, on treatments, on post-harvest treatments that can be applied or have been tried mostly at the lab scale for as alternatives of the chemicals that I mentioned before. So according to their nature, these alternatives can be physical treatments, can be reduced risk chemicals, can be biological control treatments, can be a combination of them. And also I will finish giving a few notes about the current commercial adoption of these alternative treatments. It's important not to confound here the sanitizers, which also can be used as a post-harvest treatment, chlorine, ozone, etc. Oxidizers that are used to reduce contamination, but unfortunately, they do not have an effect on already infected fruit because they kill the pathogens when they touch it, but if the spore of Penicillium is within the wound, they cannot reach this spore, so they cannot control the already existing infections. They are sanitizers, very good to disinfect, but not to control. So they cannot be substitutes of these fungicides. So as physical treatments, we can differentiate between antifungal treatments per se or complementary treatments that are used as post-harvest managing or handling of the fruit and can have an effect on the control of diseases. But as antifungal treatments per se, heat treatments, they can be curing or hot water, irradiations, gas-use shocks. These are physical treatments that can be specifically applied to fruit in order to control diseases. And the other, cold storage, control atmospheres, etc. These are post-harvest handling treatments that are used for mostly physiological, technological reasons, and can have a side effect on these incidents of diseases. So curing is we put the fruit in the big rooms in the packing house, and we increase the temperature higher than 30 Celsius and with very high humidity for a long time. This is a very, very good treatment against penicillium. It almost controls 100% of the already existing infections. The problem is that it's not a practical treatment. So if you imagine a big packing house, a cold room in which you have to increase the heat to 30 and then have that fruit stop in there for 3 days. So it's not applied commercially because it's not practical, but it's very, very good against penicillium. A way to have the benefits of heat, but in a more practical way, would be the use of hot water, just dipping the fruit in hot water. If we have seen that is also have some effectivity, but of course, by itself cannot replace the efficacy of a fungicide. We are talking that imazalil, if there is no resistant strains of the pathogen in the packing house, imazalil, if it's well applied, you can reach 90 or higher than 90% control of disease. While with hot water, maybe you can go 60, 70, depending on different factors, but it's not easy to get the same efficacy than with a fungicide. These can be different technological ways of applying. For example, hot water rinsing and brushing. This was a technology first developed in Israel, in which the hot water is applied in a short period while the fruit is rolling on the packing house, on the packing line rollers. So it's a kind of very, very hot water, and because the contact time is lower, because hot water can be phytotoxic, don't forget that. If you use too much temperature or too much contact time, you can burn the fruit, so you have to be careful of that. Irradiations, many work on many of them, as for example, Professor from Greece has explained it about UVC light. This is an indirect effect on the host that can be a good way to reduce the green mold of citrus. Other irradiations, many work have been done in ionizing radiations, pulse of light, etc. And the problem right now is the lack of, let's say, possibilities to do it in a commercial way in a normal citrus packing house. But all this information is good. We have this information, so you never know in the future. Imagine the day imazalil is completely forbidden, then the context will completely change. All this work on alternatives are generating a lot of information, which, this is not applied commercially. Yes, but we have this information, so you never know what can be used or not in the future. So right now, because, and thanks God, imazalil is still available, so in conventional production, people will keep using imazalil. But the day imazalil and other fungicides are gone, then we should to revisit all this scientific information generated by many groups working on this topic. Ozonated atmospheres, we will talk about that, is just to generate ozone gas in the atmosphere of the cold storage rooms. And it's very oxidant and need to be continuously monitoring because ozone can be not only phytotoxic, but also can affect the health of people going into that room. So have to be very careful to use it. So moving to reduce risk chemical treatments, we are talking about natural or synthetic compounds with known and minimal toxicological effects on mammals and environment. In general, we can talk about natural compounds, food additive, or generally regarded as safe compounds. These are in relation to the legislations. Food additives is an European classification, while GRAS are an American classification. Disease resistance inducers and antifungal edible coatings, that could be general groups of of these reduced risk chemicals. Natural compounds, many work have been done with plant extracts, volatiles, essential oils. And in our case, our lab are now working mostly on extracts from agri-food byproducts in order to keep working on this bioeconomy, circular bioeconomy. So we are trying to get our antifungals from residues and byproducts of the agri-food industry, because we know that, or we expect that many biocompounds that can be extracted from these residues can be used as novel antifungals. Peptides of proteins also, many other groups are working on that. Food additives, most known are carbonates, bicarbonates, and in the case of the post-harvest citrus industry, the most important one is potassium sorbate. It has been approved to be used as a post-harvest treatment, and this can be applied in the packing lines as a 2-3 minute dips in 2-3% solutions, and they are important. They are synergistic with heat. So if you heat these solutions to, let's say, 40, 50 Celsius, you can get a synergy between the effects of the heat we've seen before and the effects of these antifungal salts. Disease resistance inducers, so silicates, salicylic acid, etc. We have tried these as post-harvest treatments that were not very good. So the idea here would be to apply this in the field before harvest in order to increase the natural resistance of the fruit to the infection that will take place mostly during harvest. And antifungal edible coatings, this has been one of our main research lines, trying to develop new waxes, let's say, but to substitute the conventional waxes, which are formulated with imazalil or other chemicals, by new edible coatings with these novel antifungals. And always we are talking about something that should be food grade. So we should, of course, citrus are peeled, but these edible coatings should be able to be applied to apples or grapes or whatever. So edible coatings with two functions, the antifungal one, but also the role of a wax or a coating, the physiological gas exchange, water exchange. So in order to increase all the post-harvest quality of this. Biological control, we should restrict this name, biological control, for the use of antagonist microorganisms, because you can see in several forums that they call biological control the use of plant extracts, for example. But I would say the main stream on that is not agreeing with this definition, and biological control, we like to restrict that to the use of antagonistic microorganisms. That means the use of bacteria, yeast, and other living microorganisms to, in a kind of competition and very different modes of action. We have had this morning different talks on biological control. They try to interact with the pathogen in order that the biocontrol agent will win this war, and then you get the disease control. It's a complex field, of course, but very interesting. So because these treatments applied alone is very difficult to equal the effectivity of the fungicides, then a good approach can be to combine them. As I said, for example, a grass salt, but in a heated solution, that would be a combination. Or other types of different combinations, looking for additive or synergistic effects, complementary effects, or, for example, commercial implementation of effective treatments that are impractical. For example, I told that curing was a very good treatment. So if I'm able to reduce the time of curing in using it in combination with another treatment, then I can try to make that more practical. And just to finish about of course, you can have an alternative treatment, very good, but then if you apply it and it is phytotoxic or it is affecting negatively the quality of the fruit, it will not work. So you need also to look on the effect of analytical and sensory quality, on nutritional quality, effect on the cold storage potential and shelf life, etc., before adoption. So we got technical and yes, technical limitations, but the most important ones today are the regulatory limitations. So anything that you have to apply after harvest to fruit, to citrus fruit in this case, has to be approved as a plant protection product and include in the European Union pesticides database. For this to happen, that means very complex and long and expensive trials, and you have to prove the safety of this treatment. No? So right now, to use as a post-harvest treatment of citrus fruits, we have only food additive, which is potassium sorbate, and two basic substances, which are sodium carbonate and chitosan. I have no time to go in the difference between what are basic substances or other. So, but anyone that can be interested on these things can just ask me or Gianfranco, who is a very expert on basic substances, and he said at the first talk of the day. And just to finish, let me recommend here a book of anybody which be interested in post-harvest pathology. This is a book with my colleague in California, Joe Smilanik, that we did it a few years ago with 75 authors from 19 countries, and several of them are present here. And I would thank them again for their contribution to this book. So thank you very much.
Thank you, Luis. We have time for a few questions.
Luis, thank you very much for the very thorough presentation of overview of the available methods for the control of post-harvest pathogens of citrus. My question is, if, according to your opinion, one of all these alternative methods could be the method of choice in the future when chemicals will not be, conventional chemicals will not be available anymore. Is there any of all of these methods that would be the method of our choice?
Yeah, this would be the mother of the question, you know. There's been several seasons that saying or arriving news from Europe that imazalyl will be forbidden definitely, but so until now it has been resisting. But for example, fludioxonil, which is another chemical which is used as post-harvest treatment, not only with citrus, but other crops like pomegranate, for example, this mostly next year will be forbidden completely. So yeah, so I would say, and I tried to put here a little bit the concept, the non-pollutic integrated disease management integration concept of disease management. No? And then according to each particular situation, depending on where are you, of course, if you are a producer in Europe, you have to be into the European rules. If you are a producer in Uruguay or in South Africa, things can be completely different, or in Australia, can be completely different. I recently went to Australia and they told me they were still using Wazatin there with no problem at all. And using Wazatin is a fungicide that was forbidden in Europe at least 15 years ago. But for example, there they still use and export all that treated fruit to Asia, to China, so they had no problem there. And of course, if you are in Uruguay, you will have other. But in every particular case, I think you have to look at a kind of combination of things that can be, as the concept says, to minimize the economical losses. Here we will have factors about what is your fruit destination, for example, what is your most important market, etc. No? But in practice in Europe right now, we can only have these few food additives that I mentioned, the sodium bicarbonate and the potassium sorbate, and then maybe an essential oil that can be used, and maybe try to develop a new coating that can substitute the wax. And that's the only thing that right now can be used. But that doesn't mean that all the research information generated by many groups in the world working on this can be used in the future if new basic substances, new alternative grass salts are finally registered for this use. Because any of this has to be specifically registered for the post-harvest treatment of citrus fruit. That would be the same from other crops. If it's not in the positive list, cannot be used. So I would say the combination would be lately, 2 years, 3 years ago, a small improvement on the European legislation about the use of biocontrol agents has been obtained, but it's still very difficult to register a new biocontrol agent in Europe. In contrast to the States, there is a lot easier. So at the end, it's many factors, and all of them have to be taken into account. But I would say, of course, the solution would be kind of combining whatever you have available according to your particular situation.
Thank you.
Thank you very much, Luis, for a very interesting presentation. I wonder one thing on the biology. If you wound the citrus on the tree, usually they will not become infected. Now, what happened after you harvest the wound seems to be can be infected. Is the wounding process different when the fruit is in the tree or after harvest? Because that's the whole process. The capability of curing, fastness of curing. This is the whole. If years ago, they say that in the tree they will.
Well, in my experience, I would not agree with your affirmation in this case. I'm talking about the wounds that you are doing during harvest. During the wounds you are doing during harvest, the touching the fruit, and those wounds are the main cause of the incidence of disease of green mold that you will have at the end of the post-harvest. These are the main cause. Why? Because we know that the inoculum, at the harvest time, the inoculum of penicillium is all over the orchard. Many of the fruits are contaminated, so spores are already on the surface of the fruits. And when you harvest these fruits, you're making these wounds in which those spores went into the wound. What happened is that because this is harvest, the fruit is completely symptomless. So you harvest, but you're producing those infections that produce at that moment. And then you need a curative treatment after harvest because the infection is already produced. Of course, during packing line handling, you can produce no new wounds which can be infected, especially if the packing house sanitation is not good. But those are, in general, secondary. The main cause of the final incidence of green mold are these wounds which are made during harvest. During harvest, of course, you are talking about a wound 2 weeks before harvest. These are also anecdotal in terms of final disease incidence. So I don't know if I have answered your question.
But there should be some curing dynamics different in the tree.
To keep in time, can we
sure,
short
we
answer,
can keep
please?
Talking about. Sure.
So while Luis is taking back his place, I'll present the next speaker. It's Professor Erzsébet Carafa from Hungarian Chamber of Professionals and Doctors of Plant Protection. And she will give us her talk, broad-range trichoderma-based biocontrol to reduce post-harvest fruit loss caused by walnut fruit rot pathogens. Erzsébet, the floor is yours.
Thank you. So first of all, I would like to thanks for inviting me for this conference. And regarding even from the title, my presentation reflects some of the previously discussed problems and possibilities. So walnut are the third most produced nut crops in the world. And the Persian walnut itself is the third most widely cultivated fruit species in Hungary. And although there is a continuous increase in the acreage, there is a decrease with flotation for the production volume. Why? One of the factors for sure are because of the weather. So abiotic factors called drought, storms, and other stresses, which affect and decrease this production. And among the biotic factors, the cultivar is a question as well. But regarding the pests and pathogens, the most important ones, fungal pathogens, as well as insects, but there is a contact between them because wounds have been mentioned previously. So wound is necessary and make it easier for fungal pathogens, the infection and insect pests, different abiotic factors and cultivar susceptibility or prones may increase these wounds appearance, which will enhance the fungal pathogens infections. Moreover, because of the changing weather, we can detect some new pathogens emerging. Some of the producers asked us to help them because their previously successful plant protection technologies was not sufficient. Following the harvest, they detected a very large percentage of fruit rot. And in 1 year, something strange, green fruit drop was also reported. The later one was detected only in 2023 with unusual weather conditions when there was a colder May with a higher precipitation, and Botrytis cinerea was isolated from these rotten or dropped green fruits. And that was the first time we could prove that Botrytis cinerea can infect green walnuts, not only can appear on the stored walnut fruits. So previously, even green walnut extracts was checked against Botrytis cinerea. For the harvested fruit connected to very serious nut rot, mainly Botryosferia and Deaporta species were detected, which was previously reported in the Mediterranean region, but it was not widespreadly detected in Hungary. So we were searching for the inoculum sources, and not only these pathogens were detected, isolated not only from matured fruits, but from diseased woods, from buds, and green nuts. In green nuts, we could detect with overnight freezing incubation technique, which was developed first to detect the presence of quiescence infection for Monilinia in cherry fruits, but it can be used for nuts, for walnuts as well. It helps to decrease the concentration of the antifungal product within the green fruits. And after this incubation, we could detect all the pathogens I previously mentioned. So regarding the biological cycle of these pathogens, we can agree with Paulo and others that pre-harvest infection can be very important. And all these pathogens has a broad host range. So orchard sanitation itself cannot be a solution. Mainly Botryosferia and Deaporta can survive and can disease the woods and as well as the fruits, of course. The infection may happen during the pollination, so they are these pathogens can be present in the buds and in the wounded green nuts as well. Of course, they can be present in wounds and they can infect the wounds, the wood wounds and the green nuts wounds and as well as the wounded matured fruits. So wound needs usually is necessary for infection, in this case for these pathogens. What are the problems and how can we design a protection? The problem that, as we have detected, there are different fungal pathogens may participate in this knot rot. These fungal pathogens has a broad host range, so they can enter the orchards from other crops, from other fields as well. They have several infection routes, so we need some protection which has an elongated effective period. And it was mentioned, but it is a reality in Hungary that there is limited registered chemical pesticides, namely 1 or 2, which can be applied beyond copper and sulfur. And as Botrytis cinerea was detected, it is a well-known pathogen which has a habit very easily develop fungal resistance populations. So it cannot be a solution, not only because of the green deals, but because there are no chemicals we can use. So we thought maybe we should test some potential biocontrol agents. We detected Epicoccus nigrum in the buds. We tested, but their biocontrol test in vitro was lower than 50%. So we tried our previous isolates. Kata mentioned we have isolated from as an endophytic Trichoderma strains from a grapevine, Trichoderma gramsci, as well as the previously mentioned Trichoderma afroharsianum and simonsi were effective against different Botrytis cinerea strains in the plate confrontation test, so they could overgrow within 10 days the Botrytis cinerea, which is able to grow anyway very fastly as well. We have detected, we have checked their antifungal effect and biocontrol index against Botrytis, Dotidea, and Diaporta eris, which were isolated from walnut, as well as towards other pathogens. I mentioned only Ascomycota, but they are effective against Oomycotes and Basidiomycotes pathogens as well. And we tested them because they are in a marketed product in Hungary and it's available. Other countries need some mutual registration. And again, a problem, it was registered as biostimulant because of the long and very costly procedure for the registration of really biocontrol agents. The advantages of these strains that they were isolated from the area part of the plants. So we can use a treatment of the whole plants, not only through irrigation and not through the root system. And they were isolated from plants, so it proves that they adapted to host and its microbiome. They isolated from healthy plants from commercial vineyard. So they proved that they were effective because they could suppress the GTT pathogens, adapted agricultural practices because this orchard was a classical orchard when up to 20 pesticides application was used per year and they could remain up to 4 years. We could detect their presence. And they also adapted climatic conditions, which is very important in Hungary. They can grow as cold as 5 centigrades. So there is no limit, but they are safe because they cannot tolerate 40 centigrades and their growth is reduced at 37. So they are safe for humans. One commercial orchard tested in a big field for 2 years, and they detected that 2 times application, one for the bud protection during the pollination, and another applied for green nut protection was effective, and they could minimize the fruit loss and the rotten fruits on the field. If you are interested more, there are available publications on these topics. And 2 of our publications were appeared in Horticulture, and I would like to invite you for this newly launched special issue. If you're interested, just submit your manuscripts. Thank you for your attention.
Thank you, Erzsébet. We have time for a few questions. Looks that lunch is approaching, so the people are short of. Talking of which, before I leave the floor to Luis for the next to announce the next speaker, I just wanted to give you one more information about the lunch. There is the lunch that is organized in our student restaurant. It is on fixed price of €20, which includes soup, main dish, vegetables, salad, dessert, bottle of water or small juice. That's in this price. You can pay cash or by card, and we will take you to the restaurant. It's quite round the angle, but to avoid the problems, we're happy to reach it. Now, Luis, can you announce our last speaker?
Yeah, the last speaker of this session is E. Karoui. I don't know the first name. So she's coming from the University of Saps in Tunisia, and her talk is about the physiochemical characterization and antifungal activity of Tunisian marine macro algae against botrytis cinerea. Thanks.
Good evening, everyone. It's a pleasure for me to be here today. Okay, I present myself. My name is Itides Karoui. I'm PhD student at the University of Sfax in Tunisia. It's a pleasure for me to present my work entitled Physicochemical Characterization and Antifungal Activity of Tunisian Marine Macroalgae Against Botrytis cinerea. This work is collaborative research between Italy and Tunisia. Modern agriculture face major challenges that is a growing population, climate change, and crop losses. For the growing population, the demographic growth implies a sharp rise in food demand. So the food demand is estimated to increase by around 70% by 2050. To meet this rising demand, agriculture systems have increasingly shifted toward industrialized production. It's caused environmental problems and it can intensify phytosanitary problems by altering temperature, humidity, and weather extreme. And also it can increase crop losses and disrupt production systems that are already vulnerable to environmental stresses. Botrytis, it considered a major fungal that cause damage for the agriculture, and it named gray mold. It can cause grapes, strawberries, tomato, and onion also. Infection can remain latent in the field without visible symptoms, and symptoms develop after harvest during storage and transportation. And it can cause losses in agriculture. To control this, fungi algae are used as a biocontrol agent. We can classify it for three groups: red algae, brown algae, and green algae. It can use it as a biostimulant, biofertilizer, and control agent, and they are rich with valuable compounds, and it can use it as commercial product in forms of liquid extract, organic extract, or compost. Along the coast of Tunisia, we collected two red algae, Ithnia misiformis from Mehdia and from Sfax, and two green algae, Cladophora and Vulva, also from Mehdia and Sfax. After drying the algae and grinding into a fine powder, they were performed to physiochemical characterization, and we tested the color of the powder. So the colorimetric analysis showed that all algae powder had similar lightness, indicated comparable brightness. For Cladophora, exhibit the highest A and H value, reflecting a strong green coloration. For Ulva and Ichnia muciformis from Sphax showed a higher B and C value, indicated more yellowish and saturated colors. For Ichnia muciformis from Mehdia, presented lower A, B, and C values, suggesting less intense and duller coloration. These variations are related to difference in pigment composition and geographic origin. Also, we analyzed the water activity for all the algae. So the results show that all powder exhibits similar water activity. For the dry matter content, it was high for all the sample. For the ash content, both Ichnia muciformis present the highest value, indicated a high mineral content, while Cladophora and Ulva sample show lower ash level. For the protein content, the algae are rich in protein and are rich on protein, but Ichnia muciformis from Mehdia exhibit the highest protein percentage. But the Ichnia muciformis from Sphax exhibit the lowest content in protein. After ash content, the algae were performed to mineral composition, to analysis of the mineral composition by atomic absorption. So the results show that the algae are rich in essential macronutrient and micronutrient, and we don't detect any heavy metals such as plumb, copper, or cadmium for the algae. The fatty acid profile, after analysis of the fatty acid profile with lipid extraction, Soxclit, and followed by transterification to fatty acid methyl ester, the 4 algae are rich in palmitic acid and oleic acid. After this, the algae were performed to functional properties for the powder. So we tested the water holding capacity for the algae, and they show that the results show that the highest water holding capacity was observed for Ichnia muciformis from Mehdia, while Cladophora exhibit the lowest water holding capacity among the tested algae. We tested also the oil holding capacity, the oil holding capacity that is higher for the 2 green algae, Ulva and Cladophora, and comparing to the 2 other red algae, Ichnia muciformis. After this, we tested the in vitro against botrytis cinerea. By direct contact of the product. So we extract the hot extract. We do the hot extraction, and the results show that Ulva showed the highest inhibition in 2%, for Cladophora in 10%, for Ichnia muciformis in 10%, and for Ichnia muciformis from Sphax for 10%, and Ichnia muciformis Mehdia in 5%. We tested also the direct contact of the product with cold extract, and the results show total inhibition for Ulva in 2% and 5%, for Cladophora in 5%, for Ichnia muciformis from Sphax and Mehdia in 2% and 5%. So these results indicate that the cold extraction of this macroalga have a potential and antifungal activity against botrytis cinerea. According to Alvarez Garcia, we used the method to identify the volatile organic compound of the product, and the results show that Ulva have a good inhibition in 20%, Cladophora also in 20%, Ichnia muciformis from Sphax in 10 and 20%, and Ipnia muciformis mahdiya in 20%. The inhibitory effect increased with algal concentration, indicated a concentration dependent response. In conclusion, the studied algae are rich in protein, mineral, and essential fatty acid, making them valuable as natural fertilizer and growth enhanced in agriculture. The color and the composition variation reflect species or geographical origin. All the samples are free from heavy metal, making them safe and beneficial for agriculture use. They exhibit high water and oil holding capacity, supporting food formulation potential. For the cold and hot extract, show an effect on botrytis growth depending on the concentration, and for the volatile compound also produced by the algae, show an inhibitory effect against botrytis cinerea. Thank you.
Are there any questions for? Seems no questions. So.
Oh, there is one.
Yeah.
Okay. Very interesting topic, this seaweed, and but how popular is seaweed as food in your country? Because in European countries, seaweed is not as popular as a food, thus doesn't create a lot of waste based on seafood. As a matter of fact, a lot of European countries doesn't have even sea or consume that. That would be interesting from my side.
I don't listen, sorry. I don't hear you.
Do you want me to repeat, right? Seaweed is a very interesting topic as food. Is seaweed a popular main food in your country? Because in European countries, many of European countries doesn't treat seaweed as food. We try to introduce seaweed as food in Norway, and it's a no-no. Nobody cared about it. So that's why I'm asking how popular it is. And it's not as a food, more treated as a sort of different. Yes.
It is not popular in Tunisia, the seaweed. So
it's a marginal food waste, I would say. Okay, thank you.
Thank you.
Deb, you wanted to make a question? It's okay. Okay. We have closed a little bit earlier. It's very strange for conference that we were so good to maintain all our timetables. I would like to thank all moderators and all of our speakers. Please, can we have Thank you. Now, before we go for the lunch, I will ask our cost action leader, Professor Gianfranco Romanazzi, who has some communication for all of us.
Thank you, Slaven, and a very simple communication. You are welcome here in the cost and to take your contribution. For cost is important that you are here, but it is much more important that you sign the form outside and you sign in the proper place. Because we debated with Fernando, it was a long story, because one of the participants of the previous meeting placed the signature, but in the wrong place. So it is not possible for cost to reimburse such kind of, let's say, item. So first, be careful and remember, because you cannot be back and we cannot fix this later. Second, it will be one form for today and one form for tomorrow. And it's not the case to come and to take the signature and to go shopping, but it's part of the whole day into the Congress. So it is an investment that cost us for interaction, and we are very happy to have this very nice location and very nice place with a lot of space for interact, to show the poster. Take benefit of the poster session, because I had a very quick look. There are a lot of contents, and some of them may be far by our expertise. And I realized that the subject and the cost action, I realize it now, not when it wrote, is pretty wide. But some other can be very, very linked, strictly linked to what we do every day. And since that can start cooperation, can start interaction, also ideas for short-term strategic mission, and so on. So take care of what it is going, and take to act and to be actor of this opportunity. Okay, thank you again.
So the last technical communications, you can leave your things here. We will provide for room to be closed while we are out, or somebody will sit here. I will see what they did. Will somebody be in the room, or the room will be simply closed, locked? So with your badge in the restaurant, you just have to see the badge and everything is arranged. If there are persons who ask us to anticipate for the social dinner, now you can pay to Jelena. She's on the front desk. Or also those who would like to join, even if they didn't sign. We have some spaces. We are limited because we have the bus. That the communication with the restaurant is more simple, but the bus has a number of places, so we can't take everything. That's it. Thank you. Now we will provide this way to the restaurant.